In this next section, we're going to talk about continuous income streams. And for continuous income streams, basically what we're looking at is we have some revenue coming in from a particular company, and we want to figure out what's going to happen to that money as they invest it. Okay? So the first one, first thing to consider is RFT we've talked about before, but here I want to explicitly state that RFT is the revenue earned by the company at time t, where t is within some interval a to b. Okay? So even if we're looking at a 10-year period, so 0 to 10, t is some unknown time within that period, and the revenue at time t is the particular revenue amount earned at that particular time. Okay? So we have three types of continuous income streams that we're going to look at. And the first is what we just consider our total value. So if I just take that revenue that's earned and add it up over the time period, this gives me the total value. And so this is basically what we've said as our area. If I take all of the revenues over the interval, that's going to give me my total value earned for that period. Now I also talked about investment, and if you remember from your pre-calc class, whichever one you took, more likely 161, you talked about annuities. And that was when I took my revenue and I invested it and got some return from that investment. And so here we have two types that we're going to talk about that you looked at before. And I want to preface this by saying the equations here are much nicer than you saw in 161. Okay? So the first is the future value. And again in 161 we took basically our compound interest formula and looked at this down some length of time and tried to figure out what the future value is going to be. And once we started looking at different types of revenue streams, these equations became much more complicated. Well, here, they're all going to be basically an integral. I'm going to take the amount of money the company is earning, and we're going to invest it at an interest rate of R, compounded continuously. Okay? And so this gives us our future value. RFT e to the R, so you can think of this as the PE to the RT. There's my continuous compounding formula. But I want to do this over the entire interval from A to B. And so here the future value comes in because I'm looking at the time as some difference between my time at my point t that I'm looking at and the end of the time span, and how much interest I'm going to earn over that. So there's my future value formula. Okay. The other type of continuous income we looked at was the present value. So before we took kind of an end value, and we tried to figure out how much we had to invest today in order to get that end value. Well, here we're doing kind of the same thing, except now we know exactly what the revenue coming in is. So again, we're going to use that revenue. We're still earning interest at a rate R, compounded continuously, but now I want to look at the initial amount, as in today. So if t equals A is my start value, I want to look at what that value is at that time. So my RFT, and notice this formula looks very similar to the future value. The main difference is when I look at my interest rate, I'm now looking at the difference between the initial and my point in time. Okay? So taking this over my interval is going to give me my present value. Okay? And so we're going to look at a couple of different examples that look at both, or I should say all of total value, future value, and present value. And again, looking at the different types of revenue streams that we can have. In this first example, we want to take a company who has a constant income stream. So for each period T, they're earning $40,000. They're going to invest that money at 10% during a 5-year period. And we want to find the total value, the present value, and the future value. Okay. So in this case, like I said, because it's a constant revenue stream, all of our equations turned out to be very nice. Okay. So for total value, I'm looking at my 5-year period, so from 0 to 5, of my function RFT, which in this case is just 40,000, and I want to integrate that with respect to t. So for my total value, my antiderivative looks like 40,000 t, which I'm going to evaluate from 0 to 5. So at my upper limit, I get 200,000. At my lower limit, I get 0. So my total value is just going to be $200,000. For all of your total value, and you'll see this in the next example, the total value is always the nicest one to integrate because it's usually going to be a straightforward integration using your properties. Okay, so let's look at present value. Okay, so for the present value, again, our integral starts out the same way. It's going to be from 0 to 5 of our revenue stream. But we're going to invest it at the interest rate, which in this case was 10%, initial time minus t dt. Okay? And so here we can see, if we clean that up a little bit, it's going to be 0 to 5, 40,000 e to the negative 0.10 t dt. Okay? Again, in this case, because our revenue stream is constant, this can be done using our properties, maybe requiring a u substitution. And again, the u substitution comes in here from the exponential piece. But again, if you remember for these, that's basically just dividing out by that coefficient. So our antiderivative is going to look like 40,000 over a negative 0.10 e to the negative 0.10 t. And we're going to evaluate that from 0 to 5. Okay. So simplifying, looks like a negative 400,000, 0, e, plugging in my upper limit, which is 5, looks like negative 0.5, minus at the lower limit, notice that negative, when I do that, is going to make that positive, 400,000 e to the 0. And again, remember that doesn't cancel out to 0, it just means that the exponent is 0. So evaluating this, we're basically getting 400,000 minus 400,000 e to the negative 0.5, which is going to approximate out to 157,387.736. You can carry out some more decimals. But again, because this is money, we want to round it to the nearest cent, so I only care about that decimal place. So our present value for this one is going to equal $157,387.74. Okay. Now we can do the same thing with our future value. Okay. And again, the future value formula looks very similar to what we just did for present value. The main difference is when I go to set up my integral, again, that exponential is going to change a little bit. So I'm going to have the 0.10, but now it's the b minus t, so 5 minus t dt. Okay. Again, I want to clean this up. So we'll get the integral from 0 to 5, 40,000 e to the 0.5 minus the 0.10 t dt. And again, with a constant revenue stream, the antiderivative here is at most a u substitution. So even though I've got that minus in there, I'm still pulling out just that coefficient. So here, when I take the antiderivative, I'm still looking at 40,000 over a negative 0.10 e to the 0.5 minus 0.10 t. And I'm going to evaluate that from 0 to 5. Okay. So, at my upper limit, I'm going to have the negative 400,000 e to the 0.5 minus 0.5, which will simplify a little bit, minus, at my lower limit, we'll get that negative 400,000 e to the 0.5 minus 0. Okay, so we're basically switching some things around here. Okay, and my upper limit Notice that one's going to go to 0, so we're going to have a negative 400,000 plus, at my upper limit, 400,000 e to the 0.5. And again, it looks very similar to what we got here in the present value formula, but notice the exponents are a little different. Okay, so when I plug in, again, I can approximate this. We'll take it to one decimal place further than we need. So we'll end up with 259,488.508. Again, I use that one to round it. So our future value is going to be $259,488.51. And there you can see our three different values for those income streams, just depending on what we're looking at. So the total value should be about right in between. If I just add up all of my revenue over the 5-year period, I get $200,000. If I take that interest added to it and look at what it's worth at the beginning of this interval, I get $157,000, give or take a few dollars. And then for the future value, if I actually look at the end of that time period, so in the 5th year, there's the $259,000 that I'd have for my money. Okay, so there's a constant revenue stream for our three different types. In this next example, we're going to look at the same type of things. So again, total value, present value, and future value. But now we're going to look at ones that are not continuous income streams. Okay. So here we are given a revenue stream that is labeled at 1,000 T. The amount is going to be invested at 5% compounded continuously, and it's going to be over an 8-year period. So we want to determine total value, present value, and future value. So just like the last one, our total value is just the integral over the period. So from 0 to 8 of our revenue stream, which is 1,000 T dt. And again, of the three, this is going to be the nicest one to calculate because again, I can look and see that my basic properties work here. So taking my antiderivative, I'll get t squared over 2 or 500 t squared over the interval from 0 to 8. Plugging in at my upper limit, we'll have 500 times 64 minus at the lower limit 500 times 0. So multiplying out, we get $32,000 as our total value. Okay. For our present value, again, the setup is similar. So over the interval 0 to 8, we're going to take our income stream, which is the 1,000 T, but now we're going to invest it at a rate of 5% from the initial period to our time. Now here's where these problems get a little trickier because now that my income stream is not constant, we notice I now have my variable t in both the exponent and in the base of my expression. And so here, in order to solve, I'm going to need to use integration by parts. Okay. Again, first thing I'm going to do is just rewrite this. So 0 to 8, 1,000 t e, and I'm going to clean up that exponent, which is negative 0.05 t, integrating with respect to t. And so by parts, I'm going to go ahead and set up my table. And again, you can do this with the formula. You don't have to use the table. So my derivative piece is going to be the 1,000 t. I can see that I'm going to need to take two derivatives to get it down to 0. My integral piece will be the e to the negative 0.05 t. Integrating that, remember I'm going to divide out by the coefficient, so we'll get a negative 1 over 0.05 e to the negative 0.05 t. And then for that second one, I need to divide out again. So it'll be a positive 1 over 0.0025 e to the negative 0.05t. Signs, again, just alternate. And from there we can use our diagonals. So again, remember, we'll go across here, diagonal here. This last one is straight across, but the integral of that will give us our constant, or 0, the integral of 0. So our antiderivative is going to look like 1,000 over a negative 0.05 te to the negative 0.05t, so that's using that first line, minus, on the second line, 1,000 over the 0.0025 e to the negative 0.05t, and then minus our integral at 0, which is a constant, but here we have limits, so we'll just evaluate from 0 to 8. So simplifying this, we are going to go ahead and simplify here, which is going to give us negative 20,000 times our 8, so plugging in at our upper limit, e to the negative 0.4, so multiplying through, minus, here dividing out we'll get a 400,000 e to the negative 0.4. That's all at our upper limit. Minus at our lower limit, plugging in 0. Notice in this first one, that's just going to go to 0 because of the t. Minus over here, 400,000 e to the 0. And so we can combine some terms and simplify. So combining, we'll get a negative 160 and a negative 400. Looks at like a negative 560 e to the negative 0.4 plus 400,000. And so plugging this in and simplifying, again, we want to round this because this is money. We're going to round it off to the nearest cent. This comes out to be 24620, so $24,620.77. And there's our present value. Okay. Now, again, for the future value, we're going to do basically the same thing. The only difference, again, is that our exponent changes some. So for future value, we're looking at, again, the integral from 0 to 8 of 1,000t, there's our revenue, e to the 0.05 is our interest rate, but then we're going from the end to our time, dt. Okay. Same thing, we want to clean this up first, so we can see this will be the integral from 0 to 8, 1,000t e to the 0.4 minus 0.05t dt. Okay. Again, because of the t in both the exponent and in the coefficient, we're going to need to use integration by parts. So we can again set up our table. And like I said before, you can use your formula if you don't like the table. Notice our derivative in this case is still going to be the same. So we'll derivate twice to get it down. Likewise for the integration piece, it's a little bit different because we now have that other term up there in the exponent. But as far as the u substitution goes, the antiderivative is very similar. So we'll still get a negative 1 over 0.05 e to the 0.4 minus 0.05t. And then integrating, excuse me, one more time, 1 over the 0.0025 e to the 0.4 minus 0.05t. Okay. Again, signs will alternate. And to get our antiderivative, we're still going to use our rows. So straight across and diagonals, last line, integral of 0. Okay. So here, getting our antiderivative, this is going to look like, following that first row of arrows, we'll get a negative 1,000 over a 0.05t e to the 0.4 minus 0.05t minus, at the second row, 1,000 over 0.0025 e to the 0.4 minus 0.05t. And then again at the lower line, that integral of 0 just goes away. So we'll evaluate this from 0 to 8. Same thing, clean up, and then plug in. So plugging in at our upper limit while we clean up, we'll get a negative 20,000 times our 8, e to the 0.4 minus 0.4. So again, plugging in 8 there. Minus over here, looks like 400,000 e to the 0.4 minus 0.4. There's our upper limit. Minus at our lower limit, plugging in 0. Again, the t there, that term will go to 0. Minus the 400,000 e to the 0.4 minus 0. So we can clean some things up. So notice our exponents for the upper limit are the same. We're going to get an e to the 0 there. So we'll get the negative 160 minus the 400. So that looks like a negative 560,000 e to the 0, which is just 1, minus a negative or plus 400,000 e to the 0.4. So again, combining and plugging in, don't forget to round to your nearest cent. So our future value is going to look like $36,729. Rounding off looks like 88 cents. Okay. And again, if we look at all three values, we can see that this makes sense. Just taking my revenue stream and adding it up over the 8-year period, I get $32,000. My present value should be less than that, and even at my interest rate, I'm getting about $25,000. And my future value, I'm getting about $37,000. So there's the three different ones using a non-constant revenue stream. Again, for your homework, you're going to see both types, meaning a constant and a non-constant revenue stream. For the exam, you should be prepared to do at least one where there is a non-constant revenue stream. And of course, I'm not going to ask you to do all three of these, but you should be able to do maybe a future or a present and be able to set it up, do the integration by parts, and solve it.